In the next part of our unit, we're going to be looking at adding and subtracting rational expressions. And one of the things we're going to need to be able to do to add and subtract those rational expressions is find a least common denominator. A least common denominator is just a special name for a least common multiple, because our least common multiple will now appear between two different denominators in our problem. So today we're going to focus in on just finding least common multiples for polynomial expressions. And the technical definition says that we find the least common multiple by looking for the highest degree of each of our different factors between the two different polynomials. So for example, if I have a factor of x minus 3, and then another factor of that quantity of x minus 3 squared, the least common multiple would be the higher degree, or that higher exponent of that factor, which would then be the quantity of x minus 3 squared. I'm going to show you two different methods for finding the LCM, and you're going to choose whichever method works best for you. So we're going to start simple by looking at just finding the least common multiple between two numbers. So one of your options is when you have two numbers and you want to find the least common multiple, you can prime factor it. So we can take 8 and break it up into its prime factors. So that would be 2 times 4, and then 4 would be 2 times 2. So the prime factorization of 8 would be 2 times 2 times 2, or we could write this as 2 cubed. So that's the prime factorization of 8. And then we can go ahead and find the prime factorization of 12. So 12 would be 2 times 6, and then 6 would be 2 times 3. So our prime factorization would be 2 times 2 times 3, or if I keep that base of 2, I can write this as a power and say that the prime factorization of 12 would be 2 squared times 3. If I use my definition for finding the LCM, I would take the highest degree of each of our different factors. So my first factor I have is this base 2, and the higher degree would be that exponent of 3. So I can put 2 cubed. But then I also have this factor over here of 3, and that's got the highest degree that there is. There's just one of those. So my least common multiple would be 2 to the third times 3, or if we multiply it out, that would make 24. So the least common multiple between 8 and 12 would be 24. So prime factorization is one option that we have. Another option that we can look at is what's known as the ladder or the upside down cake, depending on how you want to look at it. And we do a similar strategy, but what we're going to do is find a common factor each time that we're going through the process. So our top tier of our ladder, or the upside down cake here, we put our two numbers. So we have 8 and 12. And I would just look at those two numbers and I would ask myself, okay, what do they have in common? What's a common factor? So I know that they both divide by 2. So I would write that common factor out there. And then in the next tier, I would write what would happen if I divide both of those by 2. So I'm left with 4 and 6. And then you look at these two numbers and you say, okay, what do they have in common? Well, they're both divisible by 2 again. So you could put that common factor out there. And then again, we're going to divide them both. And at this point, 2 and 3 do not have any common factors. So my least common multiple, if I'm using this upside down cake or this ladder method, would be the product of all of the values, the common factors and the remaining 2. And you're going to notice we end up with the same thing. I have 2 times 2 times 2, or 2 to the third, and then that extra 3. And we get 24 that way. So this just kind of keeps our data organized a little bit better, whereas here we're factoring individually and then putting the pieces together. As we're moving forward and looking at polynomials, we're going to start seeing some x's in these problems. So let's look at an example where we have some x's. So again, you're going to have two different values, and you're going to be asked to find the LCM between those two. Option 1 is to do prime factorization. So 14 would be 2 times 7. Those are both prime. And then x cubed would be x times x times x. And then for 21x, 21 would break down as 3 times 7, and then the x. And then if I want to find the least common multiple, again, I'm going to look for the lowest degree of each of the factors here. So here I have a factor of 2, and there's no other factors of 2, so that's my lowest degree. And I always put a little check mark to show I used it. My next factor is 7, and I can see that there are 7 in each of those, but the highest degree is still 1, so I'm going to put 7 to the first. And then if I'm looking, I still have this extra 3. Well, that's the highest degree of that factor. And then I have my x's. So I have x cubed versus x. The higher degree would be that x cubed. And if we multiply that out, our LCM would be 42x cubed. We could apply the cake method or the ladder method if we wanted to, and it's going to look very similar to this strategy right here. I would just write both of my numbers next to each other. That's my top tier. Look for a common factor, so I know that they both are divisible by 7, and let's pull out an x while we're at it. If I divide this by 7x, I'll be left with 2x squared. If I divide this by 7x, I'll be left with 3. And notice now, these have no common factors, so now I can just go ahead and say that my LCM would be the product of all of those outer values. So the 7x times 2x squared times 3. And again, that's going to multiply to give me my 42, and those will multiply to give me my x cubed. So you choose what method works better for you. You can do your prime factorization method. You can do the ladder method. Either way works. As we're going through and throwing these now into polynomials, expressions here, we're going to use the same strategy. And again, I'll show you both methods, and you pick whichever one works best. But we're going to start by factoring them. And what that means is we want to factor them completely. So we're going to look for GCFs. We're going to factor difference of two squares, factor trinomials, whatever it happens to be. But we're going to factor each piece. So if I'm going to do the prime factorization method, I would look here and I would say, all right, well, I know I can factor out a common factor of 3, and I'll be left with x plus 2. And this is factored completely. And then for x squared plus 4x plus 4, I want numbers that would multiply to make positive 4, but combine to give me positive 4. So that would be 2 times 2. Or, since they're the same, that's x plus 2 quantity squared. So if I'm going to use my prime factorization method, my least common multiple, again, would be the product of all of the factors taking the highest degree of each one. So I would have a factor of 3. And then I have x plus 2's. The higher degree would be this one. And that would be my LCM. And we're not going to multiply that out. We're going to leave it in that factored form. If we wanted to use the upside down cake or the ladder method, you would really have to start with that, same idea of GCF factoring. So you would start with your 3x plus 6, but you would factor that. And then you would take your x squared plus 4x plus 4, and you would factor that too. So you would start with both of those in their factored form, and that's your top tier. And then you would look for both of them, and you would look at what they both have in common. I can see that these both have an x plus 2 in common, so I would factor out a factor of x plus 2. And if I do that, I would be left with 3. And over here, I'd be left with one of those x plus 2's. Doesn't have to be in parentheses, but I did. Now when I look at these two remaining values, there's nothing left in common, so my LCM would be the product of those 3 pieces. So my LCM, you're going to notice it's the same thing. I would get a 3, one factor of x plus 2, and the other factor of x plus 2. And again, we can write that as a power by putting an exponent of 2. We're going to look at one more example together, and then you are going to go and practice finding the least common multiple so that when we go and start looking at adding and subtracting rational expressions, you're going to be ready to roll at finding a least common denominator. All right, our last example. So I want to find the least common multiple between these two expressions. So again, if you're going to do prime factorization, just take the first one. I can see that these would have a common factor of x. And if I factor it out, I'm left with x squared minus 16. And I want to keep factoring this completely. So this right here now is a difference of two squares. That's a perfect square. That's a perfect square. There's my minus sign. So I can factor this as the quantity of x plus 4 times the quantity of x minus 4. And now that is fully factored there. For x cubed minus 4x squared, again, I'm going to start. I can see they have a GCF of x squared, so I'm going to factor that out. And if I factor that out, I'll be left with x minus 4. And even though that's a perfect square with a minus sign, that's not a perfect square. So this is finished, and I'm done factoring here. So if I want my least common multiple, I'm going to look at my factored form, and I'm going to take out the highest degree of each factor. So I have the x's here. The higher degree is x squared. I have this x plus 4. It's the only power of that, so we're going to keep that one. And then I have these x minus 4s. They both have a power of 1, so that's the highest degree is just 1. So my LCM would be x squared times the quantity of x plus 4 times the quantity of x minus 4. If you wanted to use the upside down cake or ladder method, again, you would really want to start getting it into that fully factored form first. So I would take the x cubed minus 16x and go through this process here. And I would get x times the quantity of x plus 4 times the quantity of x minus 4. And then I would have my x squared and then x minus 4. So if I wanted to use the cake or ladder method, I might notice first that they both have a common factor of x minus 4. And maybe I would just start by taking that out. And if I take just that factor of x minus 4, I'll be left here with the x and the x plus 4. But then over here, I'd still be left with that x squared. When I look here, these both now have a common factor of x. So I could go ahead and take out that factor. And here I'd be left with x plus 4. And if I divide that by x, I'm still left with x. So now my least common multiple, since these don't have any more common factors, my least common multiple would be the product of those. So I like to put them from smallest to largest. So I would have these two x's, so x times x, x minus 4, x plus 4, and then obviously we can make that x squared. So you're going to notice we ended up with the same exact LCM, just two different ways of looking at it. So it doesn't matter to me whether you do prime factorization or the ladder or upside down cake method to find those least common multiples. The goal is going to be to find them, and then we're going to see how we use those to help us add or subtract some rational expressions.